students, let me just remind all of you, and I think also in the recording, that next Tuesday is your first midterm exam. It'll include everything that we have seen till end of today's lecture. And there is an assignment that I have posted, and this is at the request of a few students who asked for some sort of a practice exam in lieu of the quiz. Normally I give a quiz before the exam to give you some idea of what kind of questions to expect. So I have put what I call sample exam questions. This is your assignment 3, okay? And here it is. And the format of the exam will be exactly like this. So there are about 50 short one-liners, okay? So what would MATLAB do if you enter, for example, 5/0 or 0/0? Okay? So I would strongly encourage you to go through these, and if you have questions, if you don't understand it, come and see me. This assignment would be due next Monday. Okay? I have the first assignment graded, and I received the marks from my TA this morning, but I will post it on the Moodle, your marks for that. But the solution has already been posted. Okay? So I would again encourage you to go through the solution, and if you have any questions, feel free to come and talk to me. And if you finish what I wanted to do today in the lecture and I have time, I will take up that solution and go over it. Any feedback for me about the course, the pace, the level? Is there anybody who is concerned about the course? Any aspect of it? Yeah?
Oh, I thought you were asking if anybody was concerned about the course.
Yeah.
I just raised my hand.
Oh, can you explain what your concern is about the marks or about not understanding what I'm talking about?
Basically, right now, worried about memorizing all these different functions. Sometimes the colon operator, like example, the colon operator operates like the line space operator, kind of.
Yeah.
But you have to enter things in a different order for them to do the same thing.
Right.
And just mixing those up would be a problem.
Right. The challenge there is like the challenge in learning any new language. There is a syntax that you need to remember. Right. I'm not sure how to help other than give you training through the assignments. And you do the assignment, and as I've said in every one of the assignment, don't blindly enter into MATLAB and copy it and hide it in. That's a quick way of doing it. And the more time you spend thinking about a question, the longer the retention will be in your brain. Okay? So my recommendation, even for assignment 3, you will find the same thing. Don't just sit in front of MATLAB and type out and finish it and be done with it. You will forget as fast as you finish doing that assignment. Read the question. Try to predict what MATLAB would do. That way you are spending certain time thinking about what it will do. And if it doesn't do what you expect it to do, it's even better. Of course, if you guess it, that means you have understood it, you have retained something, because you know what to expect. That's a confirmation that you are predicting, and it really does that. That's a confirmation that you have understood what MATLAB will do. But if it doesn't do that, it's even better opportunity for you to analyze why it is. So just don't, again, after you see that it prints out a different result, don't just write it out and move on to the next question. Okay? But think about it. Why did it do? What is it that you did not interpret correctly, the way that MATLAB would interpret? After all, it is a language created by humans, but with some logic in it. It's not like a natural language. It is a computer language, so there is strong element of logic in it. And so if you spend some time trying to figure out that logic, you will be doing all right. Okay? But the order of, as you said, in the colon operator, those are the things that you need to remember. There's no other substitute for that. Okay? And the more you use it, the better the more proficient you get in using any language. So I have tried to convince my colleagues to use MATLAB consistently as the language for science and engineering. I don't know what this is doing. Okay, so We have not succeeded. So you will see MATLAB in process control, but maybe not in other courses. If I teach 2176 and if you take it from me, you will see MATLAB again. But MATLAB is a tool for solving. One of the things that I'm going to do in response to some of the concerns is, why am I learning this language? Where am I going to use it? I'm a chemical engineer. I'm not a computer scientist. And I think that's I guess a legitimate concern. So I will take problems from 2171. I have talked to Dr. Benton and asked to see what kind of problems he is doing. So once we develop certain basic skills in MATLAB, then I will show that you can use that to solve engineering problems, chemical engineering problems from 2171. So we will take that, analyze the problem, complicate the problem perhaps, and use MATLAB to solve, because right now you're solving it by hand and maybe with calculators or Excel. But we will use MATLAB. So that will reinforce, hopefully, that MATLAB is a powerful tool for solving chemical engineering problems. This is going to be an annoying thing. Keep the current color scheme. Okay, let me try that and see whether it checks up. All right, any other questions or comments? Yeah?
Are we going to have class on October 27th, Saturday makeup day?
Yes, yes. Yeah, we will have that, yeah. We just have one class a week, so I cannot afford to lose too many classes, okay? Anything else? Okay, so in the last lecture, we looked at a few MATLAB commands, and pretty soon we'll get into a stage where we can actually start writing programs ourselves, posing engineering problems for solving. But let me just briefly review the commands that you should know by now from assignment 2. That is the use of the square brackets, okay, to define an array. Starting a square bracket, putting a set of numbers, semicolon separates the next row, and then another set of numbers, and then you close it with a square bracket. That defines a matrix or an array. Okay, so it could be a vector, it could be a row vector, it could be a column vector, it could be a 2-dimensional matrix, it could be even a 3- and 4-dimensional matrix, as MATLAB would allow. To address a specific element in an array, you use the parenthesis. So there is a difference. Okay, square brackets appears typically on the right-hand side of an assignment sign, equal sign, whereas a parenthesis addresses or picks up the number from an array that you have already defined. So A2, 3 says go and pick up the value of array A, row 2, column 3, and print that out for me. And as we talked about the colon operator, it's very important that you understand what the colon operator does. There is a certain part that you need to remember, and that part is the start, the increment, and the end. So the syntax is start, where do you want to start, what is the increment or decrement, and where do you want to end. That gives you a very powerful way of creating arrays, vectors, okay, in one short syntax. Arrays need not be integers. It could be going forward, could be going backward. But some of the tricky issues that you should understand in this is, for example, if I want to say I is equal to 10 colon minus 2 colon 20. What is the interpretation? The interpretation is start at 10, go in the -2 direction, but go up to 20 in the forward direction, right? Is that possible to do? Now, what do you think it will do? It produces an empty matrix. There is nothing in there. Okay? So how do you produce an empty matrix without it? For example, you can say I is equal to just square brackets, open and close without anything. That creates also an empty matrix. Okay? An empty matrix is a matrix that it recognizes as an array in the workspace, but it doesn't have any value. Okay? For example, once I have such an empty matrix, I can add to it. For example, I can do this. This is where, once you learn a few basics, you should be able to build more complicated structures using these ideas. For example, in an exam, having taught so far what I've done, I could do this, and you should be able to explain what it would produce. What do you think that would produce? I'm going to try one by one to see if it will shut up. Okay. I equals square brackets open I comma 2. Now I is defined as an empty matrix. There is nothing there to begin with. And then I am adding element to that array I, and I'm storing it back in I. So what would it produce? Anybody want to guess? I is equal to 2. Okay. So if I want to do this again, what would it produce? Would it produce 4? I'm not adding, there is no plus symbol there, right? I am concatenating. I am adding another element to it. I'm not adding two numbers. There is no plus sign. So it cannot produce 4. It produces 2, 2. Okay? So if I do this, what will produce? 3, 5. What do you think it will produce? Two, 2, 3, 4, 5. Right? So this high is replaced by 2, 2. And then I'm concatenating another array which starts from 3, goes towards till 5. So if I'm missing the middle element, it says go in the increment of 1 by default. Okay? So the possibilities for me to examine whether you understand these things are infinite. Right? So I could put many of these variations that you should be able to tell me. If I have a line like that, what will it produce? And you should be able to understand that. Any questions on this? Okay. Then we looked at how to assign a block of variables in an array. Okay. So on the left, so the equal sign is an assignment that says whatever appears on the right hand side is going to be stored in a variable that appears on the left hand side. But you can store it in a subpart of an array. Okay. So on the left hand side, I'm saying there is a variable called A in the workspace, and take its second row and the second and third column. So there are two numbers. Replace these numbers with 5 and 6. Okay. That's what that statement is. Okay. And switch rows. For example, take A and in the row put 2, 1, 3. That is, take the second row and put it in the first place, take the first row and put it in second place, leave the third in the third place, and do for all the columns. When you have a colon, that means all the numbers in that particular row or column. Okay? So that will simply switch the rows, 2 to 1, 1 to 2, and 3. So once again, there are many, many possibilities. So even if you do all the assignment in number 3, don't expect the same question. Expect the same type of question with numbers different, with orders different. Yeah?
How do you know when to put a comma and when not?
Good question. So when the comma is the one that separates the row from the column in an array addressing context. Okay? So it depends on the context. All these commands, operators, the meaning is in the context of what appears on either side. Okay? So if I'm using an array as, for example, let me just generate A equals magic 4. Oops. I have a 4 by 4 array. So if I say A 2 comma 3, the comma there, you have to learn to think the way that MATLAB would parse it. The MATLAB will try to understand what you are typing. So it says, okay, he's typing A. So A could be a variable. So it will search in the workspace if the variable appears. If it doesn't appear, it's going to say, okay, I don't know what A is. It's going to print out an error message. Then it sees an open parenthesis. Okay? That means it's an array, because parenthesis is an array addressing thing. And the first number that follows is a row number. The first comma separates it and identifies the column. Okay? So if I do this, it's just going to print the second row and third column. But if I do this, 2, 3, following 2, I have a colon operator. So it says I'm going to generate that colon operator. So in this case, it's 2 to 3. So what do you think it will do? Row 2 and row 3 and column 3. So it's going to print 10 and 6. Okay? So the comma in that context is that. But we have also used comma in a different context, which is here, within square brackets, right? I comma 2. In this case, the comma operator is concatenation. Join these two. Okay, so when to use comma, when to use semicolon, these are all called operators in MATLAB language, in any computer language, and the meaning of these operators depends on what it is operating on either side. Okay, sometimes it's concatenation, sometimes it's array addressing. Okay, any other questions? So here I've talked about, for example, to concatenate A and B to produce a matrix, concatenate A and B with a semicolon. Okay, a semicolon concatenation means what? New rows at the bottom of that matrix A, new rows will be created. So A and B must have the same number of columns, okay, to match. And the comma concatenation is new columns. So A followed by B on the same rows, but as a new column. Okay. So there are many ways of doing the same thing. One of the commands, one of the functions is called linspace, which stands for linear spacing. Okay. So the linear spacing command allows you to generate a set of numbers when you know how many numbers you want to create. So this is where you need to remember the differences in the argument sequence. When I'm using colon, it is start and increment and end. Start, increment, end. That's a colon operator structure. Whereas linspace, it has the same function, same role, but its sequence is start, end, and then the number of data points that you want. So I want to start at 5, end at 25, and produce 5 numbers. So I don't know what the increment is, it will calculate. Okay? Whereas in the other case, I give the increment, but I don't know how many numbers it will generate. It will automatically generate as many numbers as I specify. Okay? The other thing that you need to know about the colon operator, particularly from an exam point of view, I'll kind of question you or trick you on these things, would be what would it do in a situation like, for example, 1 colon 2 colon 10. What do you think it will do? It's going to produce 1, 3, 5, 7, 9, and then 11. So it exceeds 10 at that point. Okay? So it will produce only till 9. So the last number need not exactly match with the sum. All it's going to do is, as it's creating new numbers, it's going to ask the question, have I exceeded the right side, the upper limit? If I am not, I'm just going to keep creating additional numbers until I exceed that. Okay? So that's linspace. There are a lot of these functions, and what I will hold you, I mean, there are literally 10,000 functions in MATLAB. I don't expect you to master all of them. I don't expect you to guess, but I do want you to have the courage to guess, because that's how you will learn new things on your own after this course is done. But in terms of examinations, I will hold you responsible for all the commands that I specifically identify. That means you need to spend some time after the lecture trying to figure out what these commands do. Okay, and those could be, my exam will be composed with about 80% from the assignments type of questions, and then there are some commands that I don't explicitly cover in the assignment. Those 20% may be from here, to just check that you have actually done what I expect you to do. Okay. For example, reshape is something that I will probably never have time in the class or in the assignments to expose you. Okay, so you should be able to kind of learn by yourself what that does. Now, the cumulative sum is a function. Remember, any function in MATLAB, a function is a rule that takes certain inputs, follows certain rules, and produces certain outputs. Linspace takes 3 numbers as input and produces a set of numbers as output, following a certain rule. So we need to understand and remember what these rules are so that we can use these functions when we need them. Okay? So the cumulative sum essentially finds the cumulative sum of an array. Okay? So if I have an array like this and I pass that array A to cumulative sum function, what it's going to do is the first row will be by itself, the second row will be replaced by the sum of the first and the second row. That's a cumulative sum. The third will be replaced by the sum of the first, second, and the third. Okay? So here is the output. The first row is 816. The second row is 11. 11 is obtained by adding 8 and 3. 6 is obtained by adding 1 and 5. And 13 is obtained by adding 7 and 6. That's a cumulative sum of the first and second row. Okay. Then you have the third one, which is the cumulative sum of first, second, and third, all three of them. Okay. Now there is a second argument, and the second argument would say do it on row wise or on column wise. If you put 1, it says do it in the row direction, okay, replacing the elements and summing it up. Whereas if you put 2 there, do it in the second dimension, that is along the column dimension. Any questions on that? There are lots of these commands, okay, and the only way that you get some familiarity or comfort level with it is by doing the assignments and spending some time playing with these commands. Diag is a command that we already talked about. It produces diagonals, but I wanted to show you again the context in which a particular operator or a particular function interprets these things. Okay, so we have A. So if I pass this to diag, diag is a function. Its role is to either create a diagonal matrix or extract the diagonals from a matrix. So if the argument that I pass to diag is a matrix, like in this case A is a matrix, diag will know that, and it will extract the diagonal elements from that. So it's going to produce 16, 11, 6, and 1. Okay? So that is automatically stored in a variable called ans. But I could store it in a different variable called d as a vector. D is now a vector. Okay? Now, if I pass a vector to diag, it's going to create a matrix with that vector along the diagonal. Okay? So the reason that we are doing all these things is as we go later on to solve specific problems in chemical engineering, you will need to construct these matrices. Yeah?
Why did it do the other diagonal?
That's a good question. Why didn't you do the other diagonal? The answer is that's how these guys built this program. Now, I can tell you, write a function that will extract the other diagonal. This is from top left to bottom right. I can say, ask you as an assignment. Later on in this course, I will do that. Write a function that will say extract the diagonal from the top right to the bottom left. Okay. Now, can you maybe think of how you would do that? You can use the functions that you already know. You're going to use the functions that you know. Okay. So what does A transpose do? A transpose, is it going to be helpful? Not really. Just switches the rows and columns. Yeah.
What if you put in diag B?
Diag? D?
B.
B, what is B? You have to define what B is. If I say diag B, what do you think it will do? It will produce an error. Why? Because it doesn't know what B is. Undefined function or variable B. If you define B to be a particular quantity, then it will know what to do. For example, if B is defined as 2:5, now B is a vector. Now if I say diag B, it will take that vector and produce a diagonal matrix with that vector on the diagonal. Okay? Now, yeah.
What if you sort of like flip the whole matrix over and then take the diagonal?
That's probably the answer. There are a number of other functions that I will hopefully cover some of them today. One is called, there are a number of functions that can do. Rotate 90. It will rotate the matrix by 90 degrees, or flip upside down, or flip left to right. There are a number of these functions. Okay? So you can use that and rearrange it and then pass it to diagonal. Okay? So maybe let's take that and see what it will do. Okay? Rot 90A. Let me first print out A again so that you see what it is, and then rot 90A. Do you see what it has done? It has rotated it by 90 degrees in the counterclockwise direction. So that 13 has gone to that. So this entire column has gone to the top row. It's like rotating that matrix by 90 degrees. Okay? So in the process, what has happened? The 13, 10, 7, 4, that is these elements, okay, have become on the diagonal. So if I say diag rot 90A, Now, if I type something like that, you have to understand how MATLAB parses that. Okay, so this is like passing a function to a function. So it will start from the innermost. It will say, okay, A is a variable defined in the workspace. I know, I can get that. That is passed to a function called rotate 90. Okay, so the rotate 90 then sends an output, which is what we see here, and that output is sent to diagonal. Okay, so that is the way that you would manipulate that. Yeah.
If you did diag ants, would you get the same thing? Like
Exactly. Very good. That's what I want you to observe. Ants was the answer stored by rote 90. Not now and not anymore, but previously, right? But so you could have just taken that and passed it to diag, and that would have done the same thing. When you are doing that, you are thinking, you are observing, you are learning. Okay? And that's important. That's how you learn any language. Any other questions? Okay. So diagonal, when it sees a matrix, it pulls out the diagonal elements of the matrix. But when it sees a vector, constructs a diagonal matrix. But it can take a second argument as an input. And that argument tells you how many offsets you want from the diagonal to construct or to extract. For example, if I say diag b, 1, a possible question in your midterm exam. Okay, b is defined as a vector before, which contains 2, 3, 4, 5. It's a vector of length 4. Okay, so what do you think this would do, and what would be the dimension of that matrix? So the meaning of that diagonal in this case is takes the element vector b and put it not on the diagonal, because it has a second argument 1, so it's put it above the diagonal. Okay, the 4 numbers above the diagonal. So there are 4 numbers above the diagonal. That means it must be a 5 by 5 matrix. Okay, so if I don't have that, see what happened. It creates a 4 by 4 with the thing on the diagonal. If I put -1, what would happen? It will put below. If I put -2, what would happen? Exactly, you guys got it. Okay, and that's, you have to remember a little bit of what diagonal does. But once you do a problem like this, then you can answer any variations on this. Yeah.
So on the test, if you ask a question like that, we just have to write.
Right.
We'll put the row.
No, write the output.
Just actually.
Yeah, write the output. Yeah, you'll have enough space to actually write the output of what MATLAB does, not an explanation. Okay, I want the output. Okay, so much for diagonal. And I think again, I talked about it in the last lecture. The array addressing can be done either as a subscript with 2 numbers or as an index. Okay, so if this is a 3 by 3 matrix, the number here can be either addressed as A2, 2 or as A5 with just 1 index. And the numbering scheme is it goes along the first column, then the second column, then the third column. So A9 would be the same as A3, 3. Now, if the matrices are 100 by 100, how do you figure out this equivalence? MATLAB has a small tool for you, and that tool is called IND to sub, index to subscripts or subscripts to index. So if you know the subscripts, you can calculate what the index is. If you know the indices, you can calculate what the subscripts are. Okay. So there is an example there, and I guess I want you to study that. Do you want an illustration with MATLAB, or you guys understand what that does? Okay, let's just go to MATLAB. We have A. So if I want A 3, 2, I'm saying third row, second column. It's going to print out 7. Okay, but I could address the same element by simply giving a number, single number. What would that number be? You have to count column wise, so you have to go 1, 2, 3, 4, 5, 6, 7. Okay. Third row, second column, the array element is 7. So if you do that, it will print the same number. Okay. Do you understand it? So if I say, for example, let me take another example, A2, comma 3, what would that print? 10. What would be the single subscript position for that? 10. I guess we are lucky. 10th is always 10, 7th is always 7. Okay? So there is an equivalence between these two ways of addressing the arrays, and there is a function that allows you to calculate one given what the other is. Okay? Find. Find is a function that finds a certain condition. Okay? So its input argument is a vector or a matrix, but it could be a logical expression. Okay? So we need to understand what logical operations are. So let's go to MATLAB, and in fact let's look at first arithmetic operations. You are familiar with arithmetic operations: multiplication, division, addition, subtraction, exponentiation, etc. Okay? And are you familiar with precedence ordering? This you must have learned in high school algebra course, right? What does precedence ordering mean? Pardon?
Is that like, please excuse my dear Aunt Sally?
Yeah, that could be it. I haven't learned that particular way, but so the sequence in which the operations are carried out, and that's a mnemonic that you may remember it. Okay, so there is in MATLAB, there is a help on the precedence ordering that I have put in the notes, but let me just illustrate the idea. Okay, so if I had, for example, 25 divided by 5 to the power 2 plus 9 times 2 to the power 3. I'm trying to do some calculations here, okay? But how is MATLAB going to interpret that? Because I haven't put parentheses to indicate what I want to do first, okay? So the rule is, I don't know what that mnemonic is, but exponentiation is done first, and then multiplication and division, and then addition and subtraction. So in this case, MATLAB is going to parse this, and it will say, okay, I have 5 to the power 2. I cannot divide 25 by 5 before I do 5 to the power 2. I must do 5 to the power 2 first. Okay? And similarly, there is 2 to the power 3. And you are sure to get questions like this in your exam to just make sure that you understand it. Okay? So can you guess what this would produce?
73.
Pardon me? 73. There it is. So you have the right precedence ordering structure, how it does that. So what it actually does is, if you want to do the sequence, let me write it here, 25 divided by 5 to the power 2 plus, what did I have? 9, 2 to the power 3, multiply. So every operator will have an operand on the left hand side and on the right hand side. So here division is an operator, exponentiation is an operator, plus multiplication for star and exponentiation. The first step that MATLAB would do is do all the exponentiations. So it will figure out 25 divided by 5 to the power 2, 5 times 5, which is 25, plus 9 times 2 to the power 3. Okay? 2 times 2 times 2, which is 8. That will be the first reduction, first ordering all exponentiations. Then multiplications and divisions. Okay? And in here it will start from left to right and carry out. So here 25 by 25, which is 1, plus 9 times 8, 72. And then addition and subtraction as the last one. Okay? So that precedence ordering that you must know, and arithmetic operators, the various operators that are used in MATLAB and in most programming languages. Okay? And similarly, you have logical operators. Logical operators will compare two things. Okay? So in MATLAB, for example, when I say d is equal to 5, that equal sign is an assignment. So it says take 5 that appears on the right hand side, assign it to a new variable called d and store it. Whereas if I say d double equals 5, it has a different meaning. Now it says, it's asking the question, is the variable d the same as 5? Are they equal? So it's a logical operation. And the answer would be true or false. If it is 1, it is true. If it is 0, it is false. So D is actually 5, so it is true. Now if I ask the question D equals 6, what will it do? It will provide 0. Now that's a logical operator. Okay. So if I say A greater than 7, let me again print out A greater than 7, one of them is a matrix, the other one is a number, scalar number 7. What it will do is it will apply that and ask the question for every element in A. Is 16 greater than 7? Yes, it will put a 1. If 2 greater than 7, no, it will put a 0. So it will return a matrix containing zeros and ones. Okay, and that will identify which elements in the array satisfy that condition, that A is greater than 7. This would be an extremely useful operation. For example, you are dealing with plant data and you have time versus temperature from a distillation column. And you want to know at what time the temperature in the distillation column exceeded 95 degrees. Okay, so you have a whole series of data, 2 columns of numbers. And by using this operation, you can first find out whether it was greater than 90 ever. And using that information, you can then find out what time period it was greater than 95 degrees, for example. So those are the conditions where you would use things like that. Now the find command, A greater than 7, what is it going to do? What is this output? That's going to be all the elements where that condition was satisfied. So find finds all the elements in that array where the condition was satisfied. But how does it return that information to you? It returns in column major numbering. Okay? So these are 1, 3, 6. For example, 1 is the first position, 3 is the second position, 6 is the third position, 8 is the fourth position. These are the numbers in the array where the condition was satisfied. Now you want to know what are the actual values when it exceeded 7. How would you answer that question? Do you understand the question? So I know which positions in the array A that met that condition. A was greater than 7. Okay. Now I want to know what are the actual values. By how much was it greater than 7? So all I have to do is, this is where the single array helps. So I already have in ANDs the position locations in the array in the column major fashion as a single index. Okay. So A ANDs basically says, okay, these are the actual values. 16 was greater than 7, 9 was greater than 7. Yeah?
Could you also do A parentheses find A greater than 7?
Let's try that. A greater than 7. Will it work? How many of you think will it work? It should work, right? Because it's exactly the same thing that we did. Except A greater than 7 was stored separately and then passed. But this way, A greater than 7 will produce an output, and the output will be automatically passed to A. These are the type of questions that are kind of higher level understanding that you will find. About 10% of the questions in an exam will be of this type, where I don't explicitly cover this in the class, but you should say, oh, this makes sense, you should produce that. Right? That's a very good observation. Any other questions? Okay. Am I going fast? Am I? Okay. So that's about find. Now, this example illustrates several ways that find can return the answers. One of them that I showed you is when you just type find A greater than 7, it returns the index numbers in that array where the condition was satisfied. But find can also give you directly the array subscripts I and j and the actual value v. Okay, so let's use it in this form and see what it does. Okay, so the output from MATLAB functions can be more than one number. Okay, if you don't specify any placeholders, it will just return one number. As we saw, find a greater than 7. So find is a function, the argument is a greater than 7. Okay, and it returns one set of numbers which are the positions in the array where the condition was met. But if I pass I comma j comma v as equal to this, then the find function says, okay, this user is more sophisticated, he wants additional information. While parsing it, the function will know, okay, because it counts how many variables you have passed and how many variables you expect. And in this position, it will pass some numbers, and I want you to kind of interpret that. Okay, what would be the I, and what would be the j, and what would be the v? Maybe I should take a, so that you can see it in the screen. Magic 3. Okay, then let me run that again. So you can see the matrix and its output. Can you now make sense, logical sense out of it? What did it do? How will you use that information? If you feel comfortable doing this, you are good, well positioned to learn MATLAB kind of on your own. Okay, and that's really my goal, not to teach you MATLAB, but to teach you how to learn MATLAB on your own, using only a few examples that we have once a week. What is the interpretation for this? What are the numbers that you're seeing? I would be the row number, exactly. J would be the column number. And V is the actual value where that condition was satisfied, where the logical condition was true. Okay. Remember, A equal to 7 in this case is going to produce 1. What will be the next number it will produce? If I enter this, what will it produce is a very legitimate midterm question. It will produce a vector. What will be those numbers? 1, 6. That's it, because there are only two numbers that satisfy greater than. Okay. Now, if I did this, greater than or equal to, one, 6, and 8. Okay. So remember, so all these variations are possible. Less than, equal to, all these are legitimate questions in the midterm exam. Yeah. V. Yeah. What is V? V is the actual value of the resultant. So the resultant in this case is a matrix called A and S, which has just 1, 0, 0, 0, 0, 1, 0, 1, 0, right? So when I pass this to find is going to tell me which rows, which columns, and what are the actual values. In this case, the values are going to be just 1. Okay. The third element in this is this one says which row, J says which column, and V says what is the actual value. Okay. So when I hit return on this one, I get 1, 3. Okay. So 1. That goes with this 1, row 1, column 1. That is the first element, and its value was 1. Okay. The second one is row 3, column 2. Row 3, column 2 is this one. Okay, and its value was also 1. So I think there is a legitimate reason for confusion here, because what we are passing to find is not A itself, but the result of A greater than 7. Right? Do you understand that?
On the example for it, the value for it wasn't 1.
Pardon me?
It said that B was equal to 1 and 1.
Yeah.
But the values weren't 1.
The values of A are not 1. But the values of the resultant of A greater than 7 is 1. If I type A greater than 7, the matrix has only 1s and 0s, which tells me which elements satisfy that condition, which elements did not satisfy that condition. The 1 there means in that position I had that element greater than 7. So it is this matrix that is passed to find. Okay. So let me do this. For example, V is equal to A greater than 7. So what will be V? V will be the matrix that contains 1s and 0s where that condition was satisfied. Now I'm saying find V. Okay. Now the V on the right hand side is going to be this matrix, which will contain the actual values of ones and zeros only, right? And so this analyzes this matrix and finds out where are the locations where it is not 0 and what is its value. Its value is going to be 1. That's the one that is passing in the third. Yeah.
Is the I, J, and B just like arbitrary numbers, or do they like actually stand for values? Like, can you put A, B, and C and still get the same thing?
Yeah. You could call this anything you want. Is that what you're asking?
Yeah. Like.
So if I say A, comma B, comma C, the output from find is going to be stored in those variables. Okay, so that would be perfectly fine. But if there was an A before in the workspace, it will be overwritten with this value of A. Okay, are you clear with that? What's happening there with the V? Okay, because that is, you expect those values to be the values of A, but it is not. It is the values of the output from A greater than 7. Yeah.
So that really doesn't tell you anything at all. It's always going to give you a 1. I don't understand the point of that.
Well,
like, you want to know the value of that point, so why would you do that? Because you're going to get 1.
Yeah. If you want to quickly get the value of this, this is the one that's going to get you. What happened? Oh, I guess I overwrote A. Okay. This is the one that tells you what the actual values are.
So that one's important.
That one is important. The other one gives you the values of the resultant matrix, which is true or false, 1 or 0. Okay. Remember, MATLAB gives you a variety of tools for doing many things, and it is up to us to pick the right tool to solve a particular problem. Pretty soon, after 2 more lectures where I introduce functions, we will start doing problems in MATLAB. At that stage, you will be using all these functions as we need. So our learning mode will change from simply seeing command after command, which could be boring, to problem-driven one, where this is the problem I want to solve. How do I pick what are the commands that I need from MATLAB to solve that particular problem? Okay. Okay. Rotate, flip, up and down, left, right. We saw those, and you need to play with this. Now here is a function. I wanted to actually talk about this function sort. Just like find, sort is an important function. And I'm illustrating that using the ceiling and floor. So let me switch to this. So I'm going to create a vector called x. Okay. So I have entered a set of commands very much like what you will see in your midterm exam. Okay. So what will be the output of this? Now, this you cannot really predict because rand is a random function generator, random number generator. So it's going to generate numbers randomly. Okay, but the 4,1 says create a random vector with 4 rows and 1 column. The first index is number of rows. Okay, and random number function will, if I just did rand 4,1, it will create a random number between 0 and 1. So the first thing I did is I multiplied that by 10. So that I want integer numbers, okay? And then I passed it to ceil. Ceil is a ceiling which rounds it upwards, okay? So for example, if I take ans, multiply it by 10, and then pass it to ceiling, what do you think I will get? Understanding what ceiling does. Ceiling rounds it upwards. So multiplying it by 10, 0.63 will become 6.3. So what will 6.3 become? 7. Similarly, 0.09 becomes 0.9, rounds it up. Obviously, there is another function called floor, just like ceiling. It rounds it towards minus infinity. Okay? So there are many, many tools like that. So the function I actually wanted to show you is sort. What does the sort do? Okay? So here I have, let me store this in x. I guess I don't want to do that. Okay, x equals ceil rand 1,4 times 10. What will this produce? A row vector between 0 and 10 in a random fashion. Every time you do this, you'll get a different set of numbers because it's a random number generator. Okay? And then I'm saying I'm going to sort x. What do you think it'll do? From the name, you should be able to guess. It'll sort it by default from lowest to the highest. So it puts first 5, the lowest number, the next highest number, the next highest number, and the next highest number. Okay? Now sort can take also two indices, I, comma, j, comma, in fact 3 I think. I guess not 3, only 2. So what is the meaning of this? Okay, the first one tells you the sorted value. The second one tells you which position it occupied before sorting, the index position. Okay, so I think we're almost out of time. What I want you to do is look at all the 4 lecture notes. Okay, the notes and the 3 assignments. You'll be responsible for all of those in your midterm exam. Okay.